Today we will see the last topic from indefinite integral, integration using partial fractions. So let us start our session, integration by partial fraction. Now what is meant by partial fraction? Okay, the first one is if f of x and g of x are two polynomial, they are polynomial functions, then f of x and upon g of x, where g of x is not equal to 0, is called rational algebraic function. The ratio of two polynomials. So it is called rational algebraic function. So if f of x and g of x is called a proper rational function, when we say that is a proper rational function, provided the degree of numerator is less than degree of denominator. If this condition holds, then this fraction we called as a proper rational function. If it is not there, if that is, if degree of numerator is more than the degree of the denominator, then it is not a proper rational function. It is called as a improper rational function. Now we can convert this improper rational function into a proper rational function. How? We actually divide the numerator by the denominator and write it in the form of quotient plus remainder upon g of x. Now here the degree of numerator will be less than the denominator and it becomes a proper rational function. Now let us see the three different types of the proper rational function f of x upon g of x, where the denominator g of x is expressed as how the denominator is expressed a non-repeated linear factors. What is mean by a linear factor? A factor which is of the form ax plus b. This type of factor is called linear factor, linear. And if it is come only once in the denominator, it is called non-repeated factors. The second one is repeated linear factor. Now what is meant by linear repeated factors? So if this factor comes twice, then we say that it is linear repeated factor. Next, if the product of linear factor and non-repeated quadratic factor. The linear means ax plus b and quadratic means x square plus c. This type of factors, they are called quadratic factors. So denominator contains linear and non-repeated quadratic factors. So there are some standard rational forms. The first one, it is a rational function. It is in the proper form because degree of the numerator is 2 and degree of the denominator is 3. Here the degree of the numerator is 2, the degree of the denominator is 3. Here also degree of the denominator is 2 and degree of the denominator is 3. In this 3, 1, 2, 3, this shows the three types of the partial fraction. The first case, denominator contains linear non-repeated factors. In this case, how we do the partial fraction? So a constant upon a factor plus another constant upon another factor plus another constant upon another factor. So we will express this rational form as like this. In second case, the denominator contains linear repeated factors. So in that case, what we have to do? So a upon one factor plus b upon two factors, x minus a bracket square plus c upon x minus b. And in third case, it is the rational form px square plus qx plus r upon x minus a, x square plus bx plus c. Now here it is x square plus bx plus c is a rational, it is a quadratic factor. It is quadratic factor, and in this case, while finding the partial fractions, we have to write like this: a upon a linear factor plus bx plus c. Look at this. Bx plus c is the linear combination of the two constants b and c. So bx plus c upon x square plus bx plus c. That means that quadratic factor, bx plus c upon quadratic factor. So these are the partial fraction. These are the partial forms of the given expression. Now let us solve some of the examples using partial fractions. The first example: 3x square plus 4x minus 5 upon x square minus 1 into x plus 2. Okay. Now we can factorize this x square minus 1 as x minus 1, x plus 1. So clearly the denominator contains linear non-repeated factors. Each of these factor is different. They are not repeated. So a upon one factor plus b upon another factor plus c upon another factor. Now in next step, we will take the LCM of this right hand side. Then what you will get? So after taking the LCM, you will get 3x square plus 4x minus 5 is equal to a times x plus 1 x plus 2 plus b times x minus 1 x plus 2 plus c times x minus 1 x plus 1. Now we have to find the values of a, b and c. Now how to find the values of a and b, c? So for that, x is equal to 1. You can see these factors. Now for x is equal to 1, x minus 1 becomes 0, x minus 1 becomes 0. So these two terms will vanish and you will get only a. A into 1 plus 1 is 2 and 1 plus 2 is 3. So a into 2 into 3. So simplify it, you will get a is equal to 1 upon 3. Similarly, at x is equal to minus 1, if you put minus 1, then this x minus 1 becomes 0. Then this x plus 1 here, this third term, this also becomes 0. And you will, the remaining term only b. So you will get the value of b. Now similarly, if you put x is equal to minus 2, then the first and second term will become 0 and you will get the value of c. Then what we will do, we will put these values of a, b, c in this equation. So the given integrand we converted into this form. Actually, this is called the partial form of the given function or partial fraction. So instead of taking the integration of this, I will integrate this part. So, okay, 1 upon 3 is a constant, we can take outside. 3 is constant, we can take outside. Minus 1 upon 3 is a constant, so we can take outside. 1 upon x minus 1, its integral is log of modulus of x minus 1. 1 upon x plus 1, its integral is log of x plus 1. And 1 upon x plus 2, its integral is log of x plus 2. This here now, consider this first term and this last term. Here 1 upon 3, 1 upon 3 is there, so we can take outside that, we can take common from these two terms. Then we get log of x minus 1 upon x plus 2, because log of a minus log of b is equal to log of a upon b. Similarly, from here also I want the common, so I can multiply divided by 3 here, so I get 1 upon 3. You can take outside and then group all the terms together. X minus 1, x plus 1 bracket raised to 9. This is also using log property of the logarithm upon x plus 2. So this is the solution of the given problem. Now look at this example. If you see carefully, the each term where x is written, it is in the form of x square. If you see anywhere, it is here is also x square, in denominator also x square, x square. So for such cases, when the power of x is same everywhere, we used some alternative to find the partial fractions. How? Here in this case, we replace that power by some linear variable m, say t, m, n, whichever you like. So we replace this x square by m. So we get the proper rational function in linear form. Then we will find its partial fraction. So now how to find the constants a and b? So if you put m is equal to 5, this will vanish and you will get a value of a. If we put m is equal to -4, this becomes 0 and you will get a value of b. Okay, like this. So the given function, I can write it as 7 upon 9 upon m minus 5 plus 11 upon 9 upon m plus 4. You got it? So, but what is m? M is x square. We are not using substitution method here. We are just replacing it to find the partial fractions. Only up to partial fractions. So again, put the value x square. You get 7 upon 9 divided by x square minus 5. 11 upon 9 divided by x square plus 4. So take its integral. 1 upon x square minus a square. Its integral is given by 1 upon 2a log of x minus a upon x plus a, and 1 upon x square plus a square is 1 upon a tan inverse of x by a plus c. Simplify it, you will get 7 upon 18 root 5 log of x minus root 5 upon x plus root 5 plus 11 upon 18 tan inverse of x by 2 plus c. So the integral of given function is like this. So this is the integral of the given function. Now, if you see here, you will think of that here there is no algebraic expression and how we can use the partial fraction. So, my dear friends, we can convert these trigonometric integrand is in the algebraic form. For that, I need to multiply and divide it by sine theta so that the denominator will contain sine square theta, and which I can replace by 1 minus cos square theta. 1 minus cos square theta is sine square theta multiplied divided by sine theta because of that. And now this 1 minus cos square theta, I can write it as 1 minus cos theta into 1 plus cos theta because it is a square minus b square form. Okay, a square minus b square, it is a minus b, a plus b. Now here I will use the substitution method, put cos theta is equal to t. So sin theta d theta is minus 1 dt. So we get the partial fractions as minus 1 upon 1 minus t 1 plus t into 3 plus 2t. So a upon 1 factor plus b upon 1 factor plus c upon another factor, because each of these factors are linear and non-repeated. So take the LCM, put a t is equal to 1, you will get value of a. Similarly, put t is equal to minus 1. Now how to decide which value you have to put? So for that we have to look at these factors. It is here, it is 1 plus t. So when 1 plus t is becomes 0, when we put t is equal to minus 1. So put t is equal to minus 1. When 1 minus t becomes 0, when t is equal to 1. So we put t is equal to 1. Now when this 3 plus 2t is equal to 0, when t is equal to minus 3. So put t is equal to minus 3 in this equation. Okay, when you put t is equal to minus 3 by 2, this factor and this factor will get 0 and you will get only c. So value of c is 4 by 5. So this is the partial fractions of the given problem. Now take its integral. After taking the integral, you will get log 1 of minus 1 upon 10 log of 1 minus t upon minus 1, because here it is the coefficient of t is minus 1. So we have to divide it by to the given integral. Now here the coefficient of t is 2. So we have to divide the integral by 2. Here the coefficient of t is 1. So no need to divide. Then what is t? The t is cos theta. So put that value of cos theta here. This is our final answer. use properties of the logarithm to combine in under one log. Now 1 upon 2 cos x plus sine 2x. Here I can use a formula sine 2 theta is equal to 2 sine theta cos theta. Then I can take 2 cos x common. Then I will multiply divide by cos x, and then the value of cos square x I will put as 1 minus sine square x. Okay. And then I will factorize it or I will keep it as it is. I have two choices. I can factorize 1 minus t 1 plus t, or I can directly put sin x is equal to t. So its derivative cos x dx is dt. 1 upon 2 integration 1 upon 1 minus t square 1 plus t, 1 upon 2 integration of 1 upon 1 minus t 1 plus t 1 plus t. So that is 1 upon 1 minus t into 1 plus t bracket square. Okay, so these are the partial fractions. Now here the second type you got here, the second type, the factors are linear but repeated. And when factors are repeated, how to find the partial fractions? A upon a linear factor plus b upon one of the factor which is repeated, 1 plus t, plus another constant c upon the two repeated factors 1 plus t bracket square. So take the LCM like this. Now we have to put, once we have to put t is equal to minus 1, and one we have to put t is equal to plus 1, so that I will get the value of a and the value of c. Okay, and to find the value of the another variable b, we have to put t is equal to 0. Okay, so after putting t is equal to 0, you will get ab is equal to 1 by 4. So these are the partial fractions. Now we will integrate it. 1 upon ax plus b, its integral is log of ax plus b upon a. Using that formula, you will get the integral. Now here 1 upon ax plus b bracket square is minus 1 upon ax plus b bracket, its integral. Now what is t? T is sine x. So this is the integral of the given function. You can combine these under one log by using property of the logarithm. Now this is plus and this is minus. So we will write this term first and then minus term. Then use log of a minus log of b is log of a by b. This is the answer of the given problem. Now the next problem is tan theta plus tan cube theta upon 1 plus tan cube theta d theta. From numerator take tan theta common, then you get 1 plus tan square theta. We can write 1 plus tan square theta as a sec square theta, and then use the substitution tan theta is equal to x. So sec square theta d theta is equal to dx. So 1 upon 1 plus x cube. 1 upon 1 plus x cube. So here a cube plus b cube. I can use the formula a cube plus b cube is a plus b into a square minus ab plus b square. So use the partial fraction. Now here it is a quadratic factor. It is not a linear factor. It is a quadratic factor. And for quadratic factor, what type of partial fractions we have to find? A upon a linear factor plus bx plus c upon the quadratic factor. Then cross multiply. Now in this case, we are not able to find the values of the constants. We get the value of one constant directly because this is a linear factor. So 1 plus x becomes 0 when x is equal to minus 1. So when I put x is equal to minus 1, I will get the values. And to find the remaining values of b and c, I can put x is equal to 0, I can put x is equal to 1, I can put x is equal to 2 anywhere, any value. Okay, no problem. Or the another way is just take multiplication of all these terms together. Multiply this factor by a, multiply these two factors each other, collect the coefficient of x square, collect the coefficient of x, collect the coefficient of constants, Okay, and then equate it to the left hand side. A plus b is equal to 0, a minus a plus b plus c is equal to 1, a plus c is equal to 0. Okay, then solve these three equations simultaneously. You will get a is equal to minus 1 upon 3, b is equal to 1 upon 3, and c is equal to 1 upon 3. So these are the partial fractions of the given problem. So take integral of this fraction, separate the integral. Now here this 1 minus x plus x square, I can write it as x square minus x plus 1 by taking rewriting only. So its derivative is a 2x minus 1. So I can adjust the derivative in the numerator. Now how to adjust the derivative in the numerator? Just multiply by its derivative is 2x. Here is only x. So multiply divided by 2. You get 2x plus 2. But 2 is more. So plus 3. Plus 3. Now separate divide it. So here actually we are adjusting the terms, means we are using the f dash of x upon f of x formula. I1, I2, I3. Now integral of I1 is log of minus 1 upon 3 log of 1 plus tan theta. Integral of I2, this f dash of x upon f of x is log of f of x plus c. And for this we have to complete the square. Completing the square method use kara, we will get the 1 upon x square plus a square is 1 upon a tan inverse of x by a plus c. Now use all these integrals in this equation number 4. You will get your answer. So this is the starting point of the partial fractions. Now we will move in next lecture, we will move to the exercise problems.